Alright, so for number 3, we're asked for each letter. First part we gotta do is we have to find the domain and the range. Oh, sorry, full screen. Alright, domain and the range. So for A, the domain, okay, honestly it would have been easier if they wrote the numbers for us, but we can imagine there's a 1 here, another 1 there, so that's 1, that's 2. And then I'm just gonna count the x's here, so this would be 2, 4, 6, 8, 10, 12, 14, 16. So how I'm gonna write that is, honestly they should have just written those x values for us, but they'll be 2, 4, 6, oops, 2, 4, 6, 8, 10, oh boy, 10, sorry about that, 10, 12, so 2, 4, 6, 8, 10, 12, 14, 16. Okay, and then our range, what will our range be? Our range will be all the y values, so, oh man, these aren't going to be nice because they're not on the grid lines, because we have a 1y, 2y, then these three here are going to be, I don't know, let's roughly say like those look like, I don't know, what will we say, 2.5? Okay, then these ones here will be 1, 2, 3, 4. This one here, so it'll be 4, 5, 5.5, roughly. Honestly, this is kind of an annoying question since they didn't give us the numbers on the scale. So that's 5, 6. This one here is 7. Okay, is this a function? Well, this one's pretty easy. We can say yes it is, because each x only has one y. Oh my gosh. This is a mistake-filled video here. I'll get better. Alright, so it is a function. Alright, for B. B, okay, so for our domain, we're gonna say, okay, so this is 1 here. That's 1. This mark indicates 2. This mark indicates 3. This mark indicates 4. Once again, they didn't write these down for us. So our domain can be 1. There's nothing at 2, so we skip 2. There's a dot at 3, dot at 4, and dot at x equals 5. So even if there's multiple dots, like we don't write 1 twice, right? We only need to write it once. So we'll say 1, 3, 4, and 5 is the domain. And recall, domain is what our x values can be. Now our range, what are the y values? Okay, all these ticks is really annoying. Ticking me off, haha. Okay, so 1, 2, 3, third tick. So we have a y at 3. We have a y at 4, the next one. We also have one at the 6, 7, 8, and 9. So 2, 3, 4, wait, sorry. 3, 4, 5, 6, 7, 8. 2, 3, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Honestly, like, these ones are just super annoying. Okay, next quickly, is it a function? In this case, it's not, because, so remember, for it to be a function, every x can only have one y, whereas here we have this x, for example, x equals 1, there's 2 y's. Also at x equals 5, there's 2 y's there. So, no sir, not a function. Okay, let's take a look at C. Okay, now once again, they don't give us the x's. This is going to be really annoying. But, okay. So here our domain in set notation. Okay, so since this is a line and not just dots, if you have a line and you're writing your domain, so this line, I'm referring to this blue line right here, you always start with x, e, r, which says x can be any real number. Okay, because of the solid line, it just represents all the numbers that can be where the line is in terms of x. Like it can be For example, here it can be 0, it can be 0.111, 0.222, etc. So instead of writing all those possibilities separated with commas, I'm just going to write XER. Okay, then this line, straight line, means I have a condition on what x can be. So let's see, what's the furthest left and furthest right y can be? So left goes to -2. Okay, so the lowest x can be is -2. And it includes -2, so I'm going to say less than or equal to x. And then x, the largest it can be, looks like it goes up to 1, 2, 3, 4, and stops at 4 and includes 4. So we're going to say less than or equal to 4, and that's our domain. Next, we have our range. Okay, since once again, for C, we have a line, a graph with a line, we always start with YER. And then, do we have a condition? Well, yes, we do. Y doesn't go on forever up and down, so we have to say, okay, there's a condition, there's a limit to what y can be. So what's the lowest y can be? Once again, it's really annoying how they don't have the numbers on the graph here, but let me just count it. I have -1, -2, -3. Looks like it ends at -3.5 is the lowest. So we'll say, alright, -3.5 is my lower bound, and that's less than or equal to y. And then y will be less than or equal to what the greatest y is on this graph. And honestly, this is pretty annoying again. 1, 2, 3, 4, slightly above 4, maybe like 4.2 is the highest it goes. So I'll say that's my range. Alright, next, is this a function? Well, remember for a function, every x can only have one y. But check this out. If I follow my curve here, this part right here has, so for example, this is an x and this is an x, but they have different y's. It's like right here, for example. The same x has two y points. So in this case, we'll say not a function. Alright. Okay, and then for part D, see if I can just scroll down just a bit here. Okay, so part 1 wanted me to find domain and range. Okay, so since the graph we're given is a line and not a set of points, so that means I have to start my domain with x element r. Now I have to decide, am I going to write a curly bracket or a straight line? I'm going to write the curly bracket. If x can just be any number, it can go left and right forever. I will write a straight line if I have a condition, which means that x is limited to be between certain values or it stops somewhere. So if we take a look at this graph here, these arrows are pointing up and to the left, up and to the right. So what that means is since it's has a left pointing component and this is pointing to the right as well, that means eventually it could actually go left and right forever. That will probably take you a while to get there. That means I can curly bracket it because x can actually just be any number on the number line. Like eventually x could be 1,000. If you extended that line long enough, it would keep going right. Alright, the range is what the y values can be. So since it's a line, it means we have to start with YER. Okay, condition because y doesn't go up and down forever. So y goes up forever actually, but it doesn't go lower than what looks like 3. So we'll say in this condition right here, we're going to say y has to be greater than or equal to 3 or what our y values are. So the way we're going to say y is greater than or equal to 3, we're going to say y greater than or equal to 3. Alright, next, is this a function? So does every x only have one y? Yes. If we follow this curve around, every x only has one y. Yes, it is a function.